Love says hello. Welcome to Nanyang Technological University's virtual open house for the School of Physical and Mathematical Sciences, also known as SPMS. Woo! My name is MJ. I'm the co-founder of a science channel called Just Keep Thinking, and I will be your MC for today. We are here with the Mathematical Sciences Division, also known as MAS. Woo! All right, that was enthusiastic. Hearing this acronym MAS kind of feels rich, but if you guys do join, you will be rich as well in terms of your skills and knowledge that you will gain while studying here. So I hope you guys had your lunch. Some of you are probably eating in front of the computers right now. Don't spill noodles, don't spill soup. And with a full belly and a happy heart, let's commence this rather informative and mildly entertaining session for the next 1 hour. So for all you guys who are tuning in right now, you're probably something of a mathematician yourself. So I'm going to ask you a small question just to test your knowledge. Do you know why you should never describe someone as just average? Because it is a mean thing to say. You get it? You get it? Okay, not all math puns are terrible, okay, just some of them. Alright, so puns aside, let's get down to business, starting off with our first speaker of the day, Associate Professor Chan Song Hein, who will be giving us a brief overview of what MAS is about. If you guys have any questions throughout the session, please tweet in your questions via the Slido app on your screen, or you may also tweet in your questions via CBC's Telegram channel at NTU_math with AS. So without further ado, let's get the ball rolling by inviting Prof. Chan.
Good afternoon, everyone. I'm Chan Song Heng. I'm the head of Division of Mathematical Sciences. I'll give you a very brief overview of our division. The Division of Mathematical Sciences is part of the School of Physical and Mathematical Sciences, which is founded in 2005. The picture that you see in the building that you see in the picture is the building that we are in today. It was completed in 2008 and officially opened in 2009, so it's still a relatively young building. When we first started, we have about 10 professors, and now we currently have 34 professors and lecturers. Each year, we recruit about 10 PhD students and 150 undergraduates. Our division offers 5 undergraduate programs and co-hosts 3 undergraduate programs with other divisions and other schools in NTU. These are the pictures of the 34 professors and lecturers in our division. As you can see, they come from all over the world. And not surprisingly, a large group of them is from Singapore. Together, we cover many areas of research in mathematics. More or less, we cover every area almost every area in mathematics. I'll just give highlight to 3 specific groups in our division. First, the probability, statistics, and financial math group, which is a very strong group. The picture right in the middle is Professor Nicholas Prevost, who is very famous, not just because of his research, but also because of several books in financial mathematics that he has written. He's here with us today and is the third speaker, and he will give you a very interesting talk on financial mathematics. Next, we have the coding and cryptography group. This is in fact one of the largest and strongest group in the world. And the last group that I'm going to introduce is the Geometry, Dynamics and Learning group. This is one of the new areas that the division has identified and is growing. So we have 3 professors, 2 of them just joined, one last March, and one just joined last month. We have a third professor, Professor Grigory Eva, will join later this year. So that's the end of my brief overview. If you have any questions, please feel free to ask them at the Slido website. Without further ado, I'll hand over the time back to MJ.
Thank you so much, Prof. Chan, for that rather insightful sharing of what MAS is all about. And also Prof. Chan here looks quite similar to Bruce Lee, so that is a good reason for all of you guys to join MAS. Okay, moving on. Next up, we have Associate Professor Ng King Ming, who will be sharing more about the curriculum aspects of MAS undergraduate programs. Basically, what you have to potentially mark for the next 4 years. So Prof. Ng, whenever you're ready, please go ahead and enlighten our students out there.
Thank you, MJ. Hi, everyone. Welcome to this sharing session. My name is King Ming, and I'm in charge of the undergraduate programs and academic affairs in the Division of Mathematical Sciences. So if you have any questions relating to any of the programs or courses, please feel free to approach me. I'm also going to be teaching a first semester course. So if any of you should join us at MAS, I will be teaching you in the first semester. So welcome in advance. So this program, right, I'll be going through all the different programs. I'm sure all of you are really eager to find out. And so I'll take our way through some of the programs. So first of all, I'm going to start off with some reasons to study mathematics. I'm not sure for those of you who are interested in math, how much you really know about math in the university level. So at the university level, we are going to be actually focusing more on the higher functions that are relating to math and math skills. So we're not going to really be focusing specifically only on the technical content, but we also want to spend an equal amount of time training you in all of the associated higher order, skills that are related to mathematics. And one of the most important skills that is important, because these are all transferable, is that of a problem-solving skills. So I'll give you some examples of problem-solving skills that you can expect to be developed at an undergraduate level in mathematics. So first of all, things like pattern spotting, right? So like if you have all these figures, what's the next one? So of course, this is a very simple example, and of course, we're not going to be spending all our time in the classroom discussing puzzles. But this is kind of like the kind of skills that you'll be expected to know and to be developed in when solving mathematical problems. And this is undoubtedly a very important transferable skill, because in any area of analytical role, even when you are when we are working, is a very important skill to have. Another example is that of working backwards. So for example, if you have something that starts and then you subtract 5, 7, 5 to get to the end, 4 is much easier to know what you start with by adopting a very systematic way of working backwards, right? If you add back the figures that you subtract, then you start with 21 rather than to start trial and error and looking for the answer. So this is also a very important working backwards skill. If you have a very complicated problem and you only know the end goal, you need to be able to develop methods whereby you can arrive at the original solution much easier. Equally important is that of visualizing. We have in mathematics, you have some very abstract mathematical concepts, and it's very helpful if you are able to develop visualization skills. Working systematically, as you can see, if you have a very important piece of work, but if you have no idea how to organize it, it's going to come out as junk. And that of logical reasoning, right? Without logical reasoning, it's a very important skill as again, in any area of work, to be able to logically break down a complex problem and arrive at its solution. So these are all kind of the skills that you can expect to be developed in an undergraduate degree in mathematics. So again, I stress, it's not only the the content, the equations, the formulas, the methods that you can expect to learn. These are all very important, but we spend a good amount of time actually to develop these equally important problem-solving skills. And some of the other associated skills, right, that you can expect to have or to be exposed to is things like creativity, forming connections, logical thinking. Other related transferable skills such as computing skills, there will be 3 compulsory computing and programming related courses as part of the curriculum, which is very important in today's world. Data analysis, management, organization, communications, and things like that. These are all things that you can expect to be developed in. And finally, perhaps a very important aspect is that math is in fact present in almost every sector. With every career, all of these careers will all require some form of mathematics or mathematics-related skills, so such as the sciences, business, finance, and so on. So here are some examples of just broad, sectors in the industry that all of which recognize that a math degree or graduates in math degree has the advantage in the roles that they're looking for. So here you see the traditional ones, right? Like the finance sector, you can be an investment analyst, the insurance sector, actuary, risk management, statistical analysts, so things like government reporting. And the rest you can see actually are part of the growing industry over the past few years. So the supply chain and logistics with the with the rapidly growing sector in all this Grab and all these food food delivery services. Actually, these companies have actually played an increasing role in hiring our graduates to work, of course, in the back end to help them to manage the supply chain. Also part of the ever-growing industry in IT and computing base nowadays. If you look on the internet, a lot of jobs now require some form of data or data-related skills. So this is all related to a math degree. Cybersecurity, of course, has been specifically identified by the government as having a shortage in people trained in this area. And of course, the always there, the education sector and further studies is always an option that's available to many of our graduates. Yeah, so you can see that the math degree is really awesome. It's really flexible, and you can, opens up a whole wide range of jobs for you. So, so having discussed that, what I want to move on to now is to discuss what is the how is mathematics at NTU special? So we are one of the 2 universities in Singapore with a specialized dedicated math program. And here are some of the reasons or some of the benefits of studying math at NTU. So first of all, NTU math, our curriculum is actually designed to be flexible. There are actually many different programs that you can choose from. I'll share some of that with you on the next slide. But there are many attractive combinations, so ranging from double majors, second majors, single majors, track specializations, and so on and so forth. I'll be going through some of them. So it gives you a lot of opportunity to kind of customize your learning according to the way that you want to position yourself in the future for your future benefit. Another reason is that NTU's curriculum, not just at SPMS, but as a whole, is committed to preparing students for the workforce and also to inject as much as possible digital components, so certain programming courses and IT courses as part of the compulsory curriculum, so that these are all to address the issues of this ever-increasing need for these skills in the workforce. And finally, NTU has built a very long-standing relationship with industrial partners, and we have actually many strong internship programs. And actually starting from the existing batch onwards, all students at NTU, specifically at MAS, will have to undergo a compulsory internship program as part of the curriculum. Okay, so now this is the part where I think many people are waiting for. So here is an overview of all the programs that MAS is involved in. On the left, you see our single major programs, and on the right, we have the second and double major programs. So I'll be going through some of these in briefly. So the first thing I want to talk about is our main program, which is the Bachelor of Science in Mathematical Sciences. As well as you can pair it up with a minor in finance. So the minor in finance, the next speaker, Professor Prevost, will speak a little bit more on. Now, under this program, this is our main program. Again, most of the students who apply to mathematical sciences will be admitted to this program. So in the first 2 years, you will take the common compulsory math courses, and these are the usual ones that you can expect at the to be trained in an undergraduate math degree. So these include subjects like calculus, linear algebra, and so on and so forth. And there are some programming courses here. As I've said, this is a very important skill that all graduates should know. But from the second year onwards, you are required to choose a track, or what we call specialization, from one of the 4 choices: applied math, statistics, business analytics, and pure mathematics. So you can choose a track or a specialization in the second year, and from your third year onwards, you will be taking courses or elective courses based on what you choose for your track or specialization. Furthermore, in the third and fourth year, our last speaker, Yifeng, will be saying more about the student experience. So there's a lot of opportunities that you can involve yourself in, such as internship, overseas exchange, research projects, and so on. So we will hear some more from him later on. Yeah, so this is kind of like a very exciting program. Okay, so for the track, the 4 tracks that you can choose are from the following choices. The applied math track actually deals with specializing in using mathematical tools and models, and with a special focus on solving real-world problems. So you'll be taking courses relating to this kind of focus. For the stats track, for those of you who are interested in numbers, specifically how you can tell story given a set of data, this track will be maybe for you. For the business analytics track, basically you'll be focused on using a variety of different tools from stats, statistics, computing, and mathematics, basically to help to analyze data with the specific aim of helping businesses grow and plan their operations. So that's what business analytics is about. And finally, for those of you who want to take a more theoretical or fundamental approach, then you may consider the pure math track, which is basically the study of abstract mathematical objects and structures. So as you can see, the tracks are all there. They cover a whole wide range of different skills and areas in mathematics. So you can actually use this opportunity to kind of plan yourself, right? So you can choose your track. Usually, maybe you can choose it out of interest, or maybe with an eye of how you want to develop yourself in your future employment. Okay, so we just discussed the main program, which is the Bachelor of Science. Now we are also involved in some other programs with other schools, and I just briefly mentioned two programs: the Data Science and Artificial Intelligence program. This is a very popular program. This is joint with the School of Computer Science and Engineering, and also we have the Economics and Data Science program, which is joint with the School of Social Science and in Economics. Okay, so now next I want to briefly talk about our second and double major. So the next thing I want to discuss is the second major in data analytics. So this is a new program. It's just open for launch this particular intake. So for this second major, essentially what you do is that you have to fulfill all the requirements for the primary, which is the math major, which is all the requirements that I've just discussed in our main program. But additionally, you have to take several more modules relating to the second major, and these modules or these courses have to do with specific areas in data science. So you have to take 3 courses, which are compulsory courses from 3 knowledge area or key areas in data science, which is that of database, data mining, and data management. And then finally, you have to take a couple more electives relating to a second major. And these electives you can choose from a very exciting list of courses for math, chemistry, computer science, EEE, and material science. Mechanical engineering. Okay, so that's our second major. And finally, I want to just quickly discuss the 3 double major programs that we also offer. So together, we offer 3 double majors programs. So you can pair as a double major, you can pair math with economics, math with computer science, or math and physics. So for the math and economics program, this is run jointly with the School of Social Sciences, and this is for students who are interested in taking a more analytical approach to the practice of economics, right? So you'll learn about mathematical tools and modeling methods to help to make economic decisions and financial market analysis. And under this double major, you have to take math and econs courses in roughly in equal proportions. For the math and computer science double major is run jointly with the School of Computer Science and Engineering, and these are specifically for students who are strong students who are interested to be trained at the interface of math and computer science. As many of us know, math and computer science are closely related disciplines, and there are a lot of opportunities for them to interact, and this double program will actually train you in the best of both disciplines. Under this program, we can choose between 4 specializations, so they're kind of similar to the tracks that I've just talked about for our main program. These specializations are specifically chosen to blend the best of math and computer science. So these include theoretical computer science, cybersecurity, financial modeling, and data science. Finally, we have the double major in physics and math, which is run jointly with our sister department, the Division of Physics and Applied Physics. And this is for students who are interested in taking a more computational and analytical approach to the analysis and practice of physics and the natural world. Okay, so these are some of the exciting programs that we have on offer. Okay, the other thing I want to also just quickly point out is that as later on our last speaker, Yifeng, will also mention that apart from these curriculum activities you can be involved in, we have many other programs that we offer in in mathematical sciences. So you can have the opportunity to take things like internship programs, overseas exchange. Also, we have many different research programs that for undergraduate students, if you want to learn more about how mathematics research is done. Okay, and for my final slide, I just want to quickly just show you some of the employment of math graduates in the past 3 years. So the source is from the Graduate Employment Survey from the 2018-2020. So here on you can see some of the companies which are listed as the top hirers, as the companies who are responsible for most of our hiring of our graduates. So they include Shopee, Grab, not yet, but hopefully Grab will appear on the list soon. But we have things like, for the CPF, some ministries, and a whole range of companies. Okay, and then the top occupations, these are the job titles which most commonly appears in the survey. So they include a whole range of sectors, as you can see, ranging from statistics, data, IT related jobs, as well as businesses, finance, and so on and so forth. So so the math degree is very flexible, and as you can see, it opens up a whole range of opportunities for you. Okay, so that's it I have. That's all I have. I hope that you have learned something about our program. Due to the time limitations, obviously I don't have time to go into too much detail about the specific details. But if you have any questions, you can approach our website or join the Telegram group. Or for now, for this session, feel free to ask your questions at Slido with this code, or you can scan the QR code. Okay, thank you, and I'll hand the time back to MJ.
Thank you, Prof. Ng, for the really informative sharing. So contrary to popular belief, the mathematics degree is relevant in many of the industries out there, and the curriculum here will prepare you for the workforce in the future. So if you guys are interested, please do consider joining the MAS division here in NTU. Also, just a reminder to send in your questions via the Slido app, or you may also ask via MAS Telegram chat at NTU_math with AS. Next speaker of the day is Professor Nicholas Prevost, who will be sharing more about, mathematics and finance. Okay, this should get everyone's attention. So Prof. Prevost, whenever you're ready, the stage is all yours.
Thank you. So my name is Nicholas, and I'm going to discuss more specifically the connections between mathematics and finance and our offering in terms of teaching and education and research as well. So on this first slide, you can see an animation of something which is called the stochastic process. Actually, it's a Brownian motion, as it is called. And this stochastic process is often used as a model for the random evolution of stock prices. So that's already a connection between mathematics and finance. Finance is definitely relying on many tools of mathematics, and it's almost without any exception. So it goes from statistics and probability, of course, to computing, because after all, prices are numbers, so we have to compute differential equations, which relate to the time evolution of assets and portfolios and so on. Optimization, because of course you want to maximize your wealth, and other techniques, more recent techniques such as machine learning, artificial intelligence, and of course data analytics. And the idea here is that in comparison to the more traditional business education, mathematics can give you an edge over the business students, for example. So the idea is that you can leverage on your math skills to actually perform better and do things that others cannot do. And that's something you can see on the screen. So there are opportunities, there are new opportunities that are specific to the mathematics student. And I'm going to discuss just 3 of them in terms of programs, teaching programs that we have. It's the double major in mathematical science and economics, the minor in finance, and also our direct admission program to the master in financial engineering at the Nanyang Business School. Okay, so in terms of faculty, we have been hiring a few new faculty during the past few years. And the ones that you see here are the ones who joined us recently and who are doing mathematics in relation with finance. Not only finance, of course, but you can see topics such as machine learning. You can see deep learning, also infinite dimensions. You can see dynamical systems. All of this is related to finance and the stochastic control as well. So we are quite active in the field of finance, and we have brains and new brains, recently arrived faculty members. Okay, so what I'm going to do now, instead of continuing with a global overview, I'm going to be very short and just focus on very specific examples. So you already know that we are offering literally dozens of courses, but I'm just going to pick out of dozens of courses, I'm going just to pick 3 courses, which are regression analysis, that's statistics courses, time series analysis. So time series are used to model, again, the random evolution of asset prices, for example. And the last course is financial mathematics. And you can see that the syllabus of every course is quite rich. So here again, I'm not going to review the whole syllabus. I'm just going to pick 3 topics, one for each course. So from statistics, we are going to look at linear regression. In MH4500, we are just going to look at time series. And in MH4514, we look at assets and portfolios. So that's a very, very small percentage of what we have to offer. I don't intend to discuss everything. Now, what you can do, for example, you can plot actual market data, and you can try to model it using time series. So on this example, I'm looking at 2 very specific stocks, which happen to be Coca-Cola and Pepsi, but it could be almost anything. And you can see the time evolution of those stock prices. So if we zoom a little bit, yes, we can check that they evolve on very different price ranges and at quite different speeds, and the random evolution anyway appears less fluctuating with some form of volatility. So first thing we are going to do, we are going to use linear regression to bring them together to a same scale. And that's what you do. That's what you can see on this third graph on the left. So by linear regression, we bring them to a same scale. And now, although they evolve on different ranges and at different speeds, we can now compare them. So by comparing them, by taking the difference, we are going to build something which is called the spread. The spread. And the spread is modeled using time series. So with the tool of time series, we can do a lot of things, such as statistical testing, trying to understand the evolution of the spread, and we can even build thresholds. And the thresholds, you can see them on the pink rectangles. Based on the threshold, we can make investment decisions, such as buy, sell decisions, and we can manage a portfolio. In this very simple example, the portfolio will be based on only those 2 assets, KO and PEP, Coca-Cola and Pepsi. And we are going to build a portfolio in which we buy one asset, sell the other one, according to our thresholds. So we are swapping our investment decisions, buy and sell, according to the threshold which we have determined by our statistical methods and decisions. And the result is the last graph that you see on the right. And we can check that compared to some market standard index, we can achieve greater portfolio performance through this strategy, which is designed based on time series and linear regression. That's how we allocate a portfolio. So that was just a very simple example. But in general, we have already seen from my colleague King Ming that mathematics has so many applications. But in general, finance companies, they are looking for smart people, smart brains. And when you go for an interview, a job interview, let's say in a hedge fund, you find out that the questions that you get is quite often mathematics questions, and they call them brain teasers because they want people who think right, who think smart, and who are especially fast at reasoning. And that's exactly what mathematics is going to equip you with. Okay. So now in terms of teaching, I mentioned previously MAEO, that's the double major in math, sciences, and economics. So you go through mathematics courses, and it's of course combined with economics courses. You still have a choice of electives, so you can, just like for our math programs, you can add some flavor. It can be a statistical flavor, it can be analytics, pure math, or applied math. And you already received information about this. Now, we also have the minor in finance, so that's part of the math program. If you want to get deeper into the fundamentals and applications of finance, you have the possibility to add the minor in finance, which is adding more courses. So this includes basic courses and also a choice of electives from derivatives, securities to financial modeling, portfolio management, as we mentioned already, and risk as well, which is an important topic in finance. So when you do finance, you don't do just investment and portfolio management. You can also go to risk management, which is of course very important, because currently we are living in a world in which we are trying to control and assess and manage risks as much as we can. Last item that I'm going to describe is the Master in Financial Engineering. So you are here to do a bachelor, but you might want to see beyond the bachelor degree. You might want to go to work after the bachelor degree. You could also come back to graduate school. And in this case, you might be interested in the Financial Engineering program. This program is offered by the business school, the Nanyang Business School. It is quite competitive. However, we propose for you a special channel to apply to this program. We offer a direct admission to the financial engineering program to our own SPMS mathematics students. So in this case, you don't have to join the crowd of hundreds of applicants to the business school. You can just apply internally, and you will be admitted based on your performance in mathematics, statistics, probability, and all the things you have studied in our program. Okay, and I guess that's the end of my presentation already, so you have Slido if you want to ask more questions.
All right. Thank you, Prof. Privol, for giving us insights on how mathematics and finance are related and how it is crucial to bring in the ka-ching. Last but not least, we will have Mr. Loh Ifong, who will share more about his student life and his research opportunities here in NTU, which I hope has been rather fruitful and fun for you. Cannot say no, you're here already. So whenever you're ready, Ifong, please take it away.
Hi, thank you, MJ. Yes, I had a lot of fun as an undergraduate. So my name is Ifong, and it's my pleasure today to share my own experiences in a single degree program from the Mathematical Sciences at NTU. So the focus of my talk is to outline the different opportunities within the division, whether this is like research, academics, and so on, and this different student experience that I myself had on my own trajectory. So there's not really a prize to name this equation that approximates the curve on the screen. Rather, the three questions that we've heard recurrently is what is mathematics, and what is mathematics that could be in your life, and what can a mathematics degree at NTU bring to you. So there really is a lot that you can get out of a mathematics degree, and I really believe that the NTU's program allows us to get both like structure and depth, and I'm going to share with you how I've approached this. So to me, the key to kind of navigate like what mathematics means to me is on the top right. So there is the formal curriculum and this yourself and what you know that you value. So in the first year, I kind of tried to enjoy more of the student life while thinking through the different academic programs and what would be most meaningful to me. So on the left, you will see sort of a fun shot. This is from the SPMS orientation week. So our orientation leaders asked us to just pose with different facial expressions, and that's me with a dinosaur face, although I don't think you can see that. And so along the way, like besides this formal curriculum that we heard from Prof. Ng, we also had opportunities that just crop up all the time. And in your first year, for instance, in the first 2 months, you hear about the Simon Marais mathematics competition, and that is an avenue for learning about problem solving and just joining, and whether that sort of thing is really your cup of tea. So besides that, like you see on the right, there's me playing the guitar, part of the piano ensemble at the school level. Yeah, so for me, I kind of thought about what brought me to mathematics as well. It was also this flexibility
And at that point of time in 2016, when I first was deciding after my A-level results, there was a new data science program at US, and this whole right of like computing and importance that we've been hearing about. In 2018, likewise, when I first enrolled after national service, that was when the data science artificial intelligence program first came out. So for me, at the point of time, I was really interested in like mathematical modeling. So I thought applied mathematics was possibly an avenue I wanted to explore. So along the way, it was very important for me to kind of explore this like broadening and deepening electives. So in our first year, we get to explore like problem solving, and there's also advanced investigations that accompany the calculus and linear algebra series. If you want to dig more and how to find out like whether, again, it is something that could be of career or academic interest. So then that brings us to my second year. So I continued enjoying lots of programs in the school level as well as the university level. So on the left, you see me as a photographer, this time as a supporting committee for orientation. And then on the left, top left, that's the NTU Open Source Society. So I also mix around with the computing students at the university level. And you even see, like, if you're around, remember your own memories from the eclipse at the end of 2019. That was me being a Scrabble captain after the training, and that the night just kind of fell. Yeah, so in the second year, more opportunities also kind of turned up. And that was when we have to choose our own tracks, as well as be cognizant of the other electives that we can further pursue. So like, even though at first I mentioned that I was interested in applied mathematics, at the end of the day I chose pure mathematics because I found it to be the most academically like interesting. So it was rather the courses rather than the name of like being interested in particular mathematical models and so on. So in pure mathematics you can't inquire more about sort of impossibility theorems or like whether there are limits to not within a very specific like this course. So in year 2 you also get invited to the undergraduate research experience on campus, the Eureka program. This is on the university level. And again, there is a kind of flexibility that you can exploit as NTU student, because the Eureka program allows you to approach a supervisor that's not necessarily from the School of Physical and Mathematical Sciences. So you could even cross to like physics or like mathematics education or whatever makes sense for you in your own life. Okay, so next, in my third year, I continued to be very active, but the positions I took on took a distinctly academic slant. So one of my fondest memories was actually from the Odyssey research program. So the Odyssey research program consists of 2 parts. So the first part is the formal component. So what we refer to as the Odyssey research program is a 3-month-long summer research stint. So you will be able to find this on the website by Googling. And this one on the left is the Instagram page run by students, which was what I referred to as the second part. So as the part of the formal Odyssey program, you propose a project again, and after departmental approval, you work with a professor who is most likely within your own discipline, but it could also, again, cross disciplines. So for instance, in the picture on the right, we have the photo of our student committee, and I'm standing on the far left, and my friend on the right is actually a chemistry student, but in his last year of the Odyssey program, he actually won the Best Poster Prize for physics because his own interest was in quantum chemistry. So, but anyway, I just wanted to share because I'm very proud of this thing. So the Odyssey Student Club, we run academic talks on the basis that on a weekly basis. So on the Instagram page, you can check out some of these past talks that we had. We also run an informal like student website on top to really get students to mingle from a bottom-up perspective on top of this top support that we get from the faculty. So in fact, in this on the right, we have our Odyssey room, and as shown in the picture, we were graced by Dr. K.K. Phua, who is the chairman of World Scientific. That is a publication press, and it was really quite an honor to have him like donate books to come down that day to grace us. So it's not just like student life, but it could also feed back into like our own like interests. Okay, so next, in my third year, I continued exploring my own academic interests. So it turned out that I also chose to be quite like interdisciplinary. So my second Eureka project was in mathematics education research. So I explored this project that was listed about teaching towards big ideas in the secondary school classroom. And this research program was with a professor at NIE, and we explored what it meant to teach towards big ideas in the classroom. So not just covering the stuff that is already listed in a particular syllabus, like for example, time series analysis, but how, like whether this is a secondary school level, how do you push ideas so that they can really see like the horizon while engaging at the elementary level as well. So I was quite happy to be able to present this at an international academic presentation, and I think this really shows that we have both the flexibility to choose what works for us and also the possibility of going in depth into the particular topic that may not be quite orthodox. Okay, so the other leadership position I took in my third year was part of the SPMS club. So within the SPMS club, there is a MAS divisional club. We can just call it the Math Club, and it's really there to support mathematics students. So as you can see on the slide, these are some of the activities we have done. So we have done organized our own data science challenge, partnering with Kaggle, and we have also had a track/account advisor whose intention is to have student volunteers being just at the SPMS launch, which is a launch open to any student. And as you see on the picture in the middle, where there's a table tennis, two of the people playing table tennis, and you can just chat to see how a particular track works for you, not just from the formal level again, but on the right side of the book, at the top right, where explore informally, like what would Google interview you when you're being quizzed, and what this particular track could mean for you, and what it has meant for senior. Then we also had internship sharing, which was similarly an experience from the seniors who have came back from the internship programs. Pi Day, we explored puzzles, the MS Division Day, and the last part is the most important, that because with a supportive faculty, you can please support your student leaders and just participate as well, and you can do a lot of things. Okay, so I think I'll just quickly wrap up, as this is my own experience. So I just kept continue pushing this idea of interdisciplinarity. So there's an interdisciplinary FYP option as well, as shown on the left. You can Google it. And basically for me, I'm intending to pursue further studies in the history of science rather than mathematics per se. And again, this is the point on self-actualization, although I won't go too much into myself. So in conclusion, I think the prize is not for naming a particular trajectory, but the one that approximates your own path. So again, the three questions: what is mathematics to you, and what can a mathematics degree do for your NTU? So with that, I want to thank you, and I encourage you to apply for this program. Thanks. So I'd like to remember to ask your questions, Slido, and back to you.
All right. Thank you, Yifeng, for sharing with all of your potential juniors out there, both on your academic life and your student life. So as you guys can see, not only do the students here work hard, they play hard as well. Okay, moving on to our Q&A segment, where we'll be answering a lot of your burning questions. How many questions do we have? Oh, all right. Okay, they are all by anonymous. Let's start off with the first question. Will the math major be hard for poly students as they did not take H2 math before? Math major be hard for... You're from the JC track or poly track?
I was from the JC track.
Oh, okay. Would you like to take this question? Or perhaps one of the profs who... Does anyone have an idea how it would be like for poly students if they did not take H2 math, or perhaps there's a bridging module that they can take?
Yeah, we understand that for A-levels it's quite standardized. Everyone have the H2 math, but if you come from a poly track, depends on what diploma you have. You may have more mathematics if you're from engineering diploma. You may have very much lesser mathematics training if you are from other diplomas. So for the polytechnic students, we actually have math tests for admission, just to make sure that what we want to know is not that you already have a lot of knowledge, but that you are someone who has been interested in mathematics all along and is capable of doing some thinking. In terms of the syllabus, it's just it's just about O levels to maybe a little bit of A levels mathematics. So with that selection test, assuming you get in, you should be able to manage well. You may not have as much knowledge as you have as the H2 math students, or you may have more depending on whether you did more math or not. But what we want you to have is to work consistently when you first join NTU, especially in the first semester, and then you should be able to do. You should be fine. So you have to work hard every week. This is not a program where you just come in and then you can just postpone learning until you see the next test, like week 5, or until the final exam in week 10 or week 13. If you work consistently and clear your doubts every time we have things that you are not sure with, you should be able to do well. I mean, you should cope fine.
All right, thank you, Prof. Chan. That was a great answer. We shall move on to our next question. What is the benefit of taking mathematical science if I would like to pursue in data analytics? Professor Ng, would you like to take that?
Yeah, sure. Yes, if you've seen from my talk, we actually have quite a few different degree programs that we have on offer. So if you would like to do specifically in data analytics, as well as if you also happen to be interested in mathematics, then you can consider our second major. That's our new program that we are starting this year, the degree in mathematical sciences and second major data analytics. Now we also have several other combinations that you can also take, right? Like I've mentioned, and some of the speakers have also pointed out, that our program is actually quite quite flexible. So even if you do our main program, there's a lot of opportunities for you to take courses which are interested for students who are interested also in data analytics. So yeah, you can look at our website for more details. Now, having said that, right, of course, a lot of skills in data analytics. The subject of data analytics itself is not really that clearly defined, but it's really just broadly speaking, it's really just the analysis and processing and cleaning up presentation of data. So a lot of the skills that are related or needed in data analytics and data science roles will are related to subjects in statistics, programming, as well as some applied mathematics methods, all of which we do offer. So definitely, even if you were just to do a program in mathematical sciences without any data analytics like specific component, there are definitely opportunities for you to expose yourself to the tools needed for you. If you are thinking of maybe a career in data analytics.
All right. Prof. Rival, would you like to add on anything else to this question, since it's something about data analytics? Oh, the question is... Oh. All right, never mind. I think that's good enough. The answer from Prof. Ng is good enough. Let us move on to our next question. How will the math science degree with the pure math track help me shape my career options, though I am not good in research? Prof. Rival, would you like to answer this?
Yes, sure. You are saying you are not good in research, but actually you don't really know, because maybe you are good at research, or maybe you can become good at research. What can happen after 3 years, after 4 years? Well, we don't really know. So if you do a math degree with the pure math track, yes, it will help you shape your career options, because pure math is the foundation of all sciences. And as I said, even if you go to finance, people are going to test your math, because that's where it can be really checked whether you are smart enough to go into some challenging positions. So research is something else. Actually, research, some people are good at going into research, others are not. But it doesn't mean that the smartest people go to research, or it doesn't mean that the smartest people don't go to research. Those are two different things. So you can be fine and get an excellent job through research or without research. And again, whether you are good at research right now or not, this is something that can be decided later based on your path in academia.
All right, that's a great answer. It's very interesting. I don't think anyone will be very good at research from the very beginning when you enter university. Okay, the next question. Is the jump from JC to UniMath really big and difficult to catch up with, especially since university mathematics deals more with proofs? It's not a typo, right? Okay, proofs, yeah. Yifeng, perhaps you would like to share about your thoughts on this question, since you came from this track, right?
Yes. So as I mentioned, I came from GC into uni math, and I think it will be alright because our UC program really eases us into the practice of like understanding to prove things, for instance. So as Prof mentioned, it's actually one of the instructors who will teach you in a foundational course, and that is the foundations of mathematics. And I think that it is a really comfortable pace where we learn to like prove like elementary stuff and all the way that things that might seem obvious to you, but you have to really put a discipline into proving certain things. And I think this would be quite manageable as you put set time aside to just practice, do the problem sets, and just enjoy the experience of learning. Yeah, I think it'll be fine.
Yeah, maybe I'll just add on just briefly. So from JC to Uni Math, I wouldn't really call it like a jump in the strict sense. So it's not really like you have to like do the same thing, but like much harder versions of the same thing. It's not really that, right? The whole concept of uni math, like I've mentioned also in my talk, is more we kind of focus more on the other kind of functions in mathematics. So not specifically just on answering problems, but so it's actually quite different. So I wouldn't really call it a jump. So it's quite different. And yeah, I think you know, you can take the opportunity to if you were to join us, you know, take the opportunity to expose yourself to all this, and I hope you enjoy it.
All right. Thank you, Prof. Ng and Yifeng. We shall move on to our next question. Would we be able to have a brief taste of experience of the different specialization in the first year before getting the option to choose the specialization? So perhaps Prof. Ng?
Yeah. Okay. So the time that you choose the specialization is actually at the end of the third semester. So after 1.5 years. So in the first 3 semesters, you would have, if you go by the normal timetable planning, you would have taken a majority of the compulsory courses, and the compulsory courses, of course, will cover a whole range of different topics. So yes, so you will have a brief taste. I think by that time you should kind of know, oh, maybe I don't like stats, or maybe I really love proofs, or something like that, right? So all the courses, you would have at least one course in that will exhibit the flavor of each specialization by that time. So yeah. Yeah, so having said that, of course, some students still, by the time they get to their third semesters, they're still not really sure what is going on, and like haven't really had enough information or to make a decision yet. But don't worry, the choosing of the track is, you can always change your mind later. And also the other thing is that choosing a track does not mean that you are kind of limited. Your options are limited. No, it's not that, right? We want to really encourage students to explore all different areas. So the track is only like a declaration, and you whereby you have to focus more on courses relating to that choice. But that doesn't prevent you from choosing courses from other tracks, for example. And definitely you will have opportunities to, like if you choose applied math track, you will have the opportunity to choose courses or electives from the other tracks as well. So that is also not really limiting.
That's a great answer, Prof. Ng. Hope that answers your question as well. So let's move on to our next question. Do you have any advice for students intending to take mathematical sciences? I guess this is a question for the profs also. Would anyone like to take this question? Any advice that you would give to students intending to take mathematical sciences? Prof. Privot?
Okay, a very short advice. I think you need to be open, an open mind, being consistent in your work. So yes, being open to different theories, different concepts, because there will be very new concepts, some things that maybe you never imagined could exist in mathematics. So openness. And then, yes, it's going to boil down to hard work, consistent hard work to succeed in mathematics. I think that would be my advice.
Yeah, maybe I just add on. Yeah, so as maybe some of you may have already heard, mathematics is all about hard work, but also on top of hard work, you have to need to have consistent work and have the attitude of not giving up, because I think I'm sure all of us, right, have had experiences in doing math problems whereby maybe you get stuck for a very long time and then suddenly you just have the eureka moment where you get the solution. So this is going to happen quite a lot actually, and I think it also helps you to train your it's like a lifelong skill, right, of not giving up no matter what happens. Yeah.
All right. Thank you so much for the answers, profs. Next question. Can I study math if I am not very strong in math? Ooh. This is a tough one. Prof Chan, do you have anything to say about this question? It's a bit similar to the previous one.
Yeah, I think it'd be great if you have interest, a lot of interest in mathematics, and then of course, first of all, you get offered, and then you choose to study with us. If you have difficulty following the classes, don't feel shy to approach people for help. There are many channels that you can go to for help. You can directly approach your lecturer or the tutor for your tutorial classes, or seniors. We also have a math clinic which is run by the school. So we hire the senior. Your seniors, the senior undergraduates, to be there at specific hours. So and we pay them by the hour. So don't feel shy to go to those sessions and then ask them for help. But of course, you don't need to. Of course, you should also always consider asking help from the lecturers and tutors. Yeah. In addition, so somehow you're really shy, didn't like to talk to lecturers and tutors so much, then maybe you can go to the math clinics.
All right, thank you, Prof Chan. I think I agree with you a lot. So it's when you enter university, a lot of us just starts from the same level actually. So it's up to you to decide how hard you want to work. If there's help available whenever you want to seek help, from your tutors, from your profs, and from your seniors. So yes, join and work hard and be consistent. All right, our next question. As a math student, can I specialize in both pure and applied math tracks? So this is a question for you, Prof. Heng.
Yeah, the short answer is no, because it's just the way that the program is structured. You can only choose one specialization or one track throughout your study. However, as I've also said before, the track choice is not limiting in that sense that you cannot take, right? So if you choose a pure math track, that just means that when you graduate, you need to fulfill a certain quota, a certain number of courses listed as pure math modules or electives. But that doesn't mean that you cannot take or open yourself to opportunities in other tracks. I myself is a pure mathematician, and also I have supervised students for the final year project, for example, who are actually from other tracks. In fact, it's quite rare for me to get students in the pure math track. Students in pure math track go to other professors. I don't know, they don't go to company. But I do supervise. So these students are on other tracks, but they are actually interested in projects that I have to offer. So it's actually quite common. Yeah. So you cannot specialize, but you can certainly still have opportunities to do other stuff.
All right, that's a great advice, Prof. Ng. Let's move on to our next question. What is the career prospects like for a mathematical science graduate? Well, we did mention that earlier, but I guess someone can just briefly review through it, like what are the career prospects or what industries they can get involved with.
Okay, in one word, excellent. Excellent prospects, because we are, as you know, moving to a world which is facilitated by data, which is even ruled by data. So the mathematicians could be the next rulers in this world. So yes, they are excellent.
Yeah, maybe I just also quickly add on. So I just want to share like how things were like for me 30 years ago. No, not 30, some number of years ago. I won't say how long ago. When I was also in a position considering, what I want to study. And at that time, things were a lot more bleak for students who were considering majoring in mathematics, because at that time, the companies, industry were not really ready for to take mathematics graduates in roles which are not specific to mathematics. So at that time, if you study mathematics, you will end up probably only as a researcher, I don't know, or maybe teacher or whatever. But now today, the world has changed a lot, and the industry is a lot more open now, to hiring graduates, and they do recognize that students with mathematics degree will have an advantage over other students who are applying for competing in a similar roles which are not specific to mathematics, right? So things include things like IT roles, or so you will be competing, for example, with computer science students, or even finance roles, because of the fact that we provide analytical, critical thinking, and you also have some mathematical skills. They know that this is actually an advantage. So it's a lot better now.
All right. Thank you, Prof. Ng. And also, just remember, we have the Singapore Math, we are like globally famous right now. So unfortunately, that was our last question. And if any of you guys do have any more questions, please do send it in to the MAS Telegram chat at NTU_math with AS. Sorry. Okay, so just like some of our relationships, all good things must come to an end unless you have a relationship with pi at MAS. Then it will go on and on and on forever. Okay, so that's all we have for today's SPMS MAS Virtual Open House. Once again, just a reminder that you can send in your questions to MAS Telegram chat at NTU_math with AS. Also, do check out our SPMS tours available for limited sign-ups only on the NTU Open House website, where there will be guided in-person tours that will bring you around the common areas, the teaching facilities, and also the laboratories here. It will be accompanied by SPMS student ambassadors, and you can have a taste of what your future university life may be like. Some of the slots are already fully booked, so please head to the website to reserve a slot right now. Thank you all for joining us this afternoon. I hope you guys enjoyed the session as much as I did, and have the rest of the day to yourself. Bye-bye!